Network traffic flows quietly in the background, entirely invisible to the average user. But when adversaries attack a network, they are aiming for very specific targets. This diagram illustrates what cybersecurity professionals call the CIA triad, showing three interconnected nodes: confidentiality, integrity, and availability. These three principles are the primary targets of any cyber threat. Let's imagine a typical high school. It's a normal Tuesday when several students notice the internet grinding to a halt. Web pages won't load and shared network drives drop completely offline. This severe slowdown directly threatens the availability of their resources, meaning authorized users can no longer access the data they need to work. At the exact same time, a barrage of unexpected pop-ups begins appearing on a few student screens, indicating dozens of failed login attempts in a matter of seconds. This targets the confidentiality of user accounts, showing an attacker is actively trying to guess passwords to access private files. Looking closely at their connection settings, another student spots an unknown, unrecognized device connected to their personal hotspot. Unfamiliar hardware piggybacking on a local network is a primary indicator of compromise. In this scenario, detection begins with the users. Reporting these anomalies to the IT administrator immediately triggers the school's formal incident response. Human sensors are highly effective on the ground. Recognizing and reporting digital symptoms early prevents a minor, localized vulnerability from escalating into a major security incident across the entire school. To figure out what's happening, the IT administrator begins by comparing the current network traffic against established baselines. The flat line represents normal, everyday data flow. The sharp spike reveals the sudden, anomalous surge in traffic hitting the school's servers. Zooming in, data points reveal a massive cluster of blocked firewall events, alongside unusual transfers attempting to communicate with external, unfamiliar IP addresses. Basic logs confirm that traffic is high and errors are occurring, but investigating the actual contents of those transfers requires automated security tools designed to dig much deeper into the packets themselves. The first tool is an intrusion detection system, or IDS. It functions as a passive monitor, scanning incoming traffic for known attack signatures, like specific malware code. When it finds a match, it sends a high-priority alert. But as you can see, the malicious data block passes right through. The IDS watches, but it takes no direct action to stop the traffic. That's where an intrusion prevention system, or IPS, takes over. As an active tool sitting directly in the flow of traffic, it physically drops the packets and actively blocks the offending IP address. It spots the threat and stops it cold. An IDS provides the visibility needed to understand how an attacker is probing the system, while an IPS provides the immediate defense. Together, they are required to track and halt lateral movement, keeping an attacker from hopping from a compromised laptop into the school's central database. However, between the firewalls and the network routers and the IDS and IPS, a modern network generates millions of digital events every single day. This volume creates alert fatigue, where human responders become so overwhelmed by notifications that they miss actual attacks. To solve this, organizations deploy a Security Information and Event Management System, or SIEM. It acts as the network's command center, aggregating raw logs from every firewall, router, and sensor. Pulling all those separate data streams into one central brain, the SIEM uses artificial intelligence and correlation rules to filter out the benign, everyday noise. It cross-references events that seem unrelated on their own, identifies the true indicators of compromise, and outputs them as a single, clear warning for the IT team. The SIEM correlation reveals a calculated strategy. The network slowdown provided a smokescreen for a targeted brute force password attack against the admin server. Aggregating data across devices is the only way to see the full picture of an attack. It prevents adversaries from hiding their true objectives within the everyday noise of a busy network. When an attack is confirmed, strict response protocols kick in. For everyday users, the procedure is simple. Never attempt to investigate the adversary yourself. Instead, document details like specific error codes, step away from the device, and report it quickly to the security team. If instructed by administration, the next critical step is to immediately disconnect the affected devices from the network. Pulling the physical or wireless connection severs the attacker's access and halts the attack's ability to spread. With the threat contained, the IT administrator executes their post-incident steps. They carefully preserve the network logs so the data can be analyzed as evidence later, and force a mandatory credential reset for any accounts that may have been compromised. Protecting a modern network requires a layered defense. By combining vigilant human users with automated tools like an IDS, an IPS, and a centralized SIEM, organizations safeguard the confidentiality, integrity, and availability of their data. Together, these tools turn invisible, hidden threats into visible, actionable warnings.